Hello and welcome. My name is Dr. Raj Basood. I'm a consultant psychiatrist and I'm based in Harley Street in London, and delighted now to be joined by Oscar Fernandez. Oscar Fernandez has written a fascinating book called The Calculus of Happiness. He is Associate Professor of Mathematics at Wellesley College and the author of Everyday Calculus, Discovering the Hidden Math All Around Us. He also writes about mathematics for the Huffington Post and on his website, surroundedbymath.com. So, Oscar, what's fascinating and distinctive about your book is it's a very accessibly written book. You don't have to be a mathematician to understand it. But you're saying something deeper than the rather obvious point that maths is an important subject and we need to get a handle on math in order to understand better the world around us. You're actually saying it has a practical outcome, which is we're going to lead practically better lives, happier lives, if we embrace maths a bit more. Could you say something about that?
Of course, and thanks to begin with, Raj, for having me on. One of the really interesting things about math, and I drive this point home in the book, is that, as you say, it's not just a way to understand the world. I really try to make the case in the book that it's an empowering tool, if you will. So it can help you make sense of phenomena you might not quite understand or appreciate without the power of mathematics. For example, models of climate change. That's a very complex system, and mathematics certainly helps make sense of it. But on a more daily, everyday basis, what about your diet? What about your finances? What about your love life even? These are things that we don't normally think of using math to help us understand. But really, part of the point of the book is to help us think about math as an empowering tool, which helps us give us a little bit of a framework to dissect and analyze and deconstruct some of the complexities associated with each one of those spheres of life, as if we were trying to study the climate and develop models to understand that and predict. So all of that is a way of saying that math doesn't have to be abstract and incomprehensible and inaccessible. We actually use it, every day. And if we thought a little bit deeper about it, we can actually make it empowering and make it work for us.
Now, the other reason why I was drawn to your book is a thing that happens when people choose to study psychology or psychiatry. And those are obviously my fields and my discipline. I'm a psychiatrist, and I did a degree in psychology. The people that are drawn to psychiatry and psychology are kind of what you might call people. They want to. They like talking to people, and they're interested in emotions and love and that kind of stuff. And then they encounter the academic discipline, and they're in for a bit of a shock, which is they've got to read research studies, and they find they're having to wade through a lot of maths. And
Right.
they complain bitterly that they wanted to learn about love, and they end up reading a lot of stats. And the thing they don't understand is that for something to translate into from an anecdotal understanding of love to a scientific understanding of love, if you're going to go on that journey, maths comes into it, because maths is about measurement and maths is about precision. And isn't there some sense of resistance in many people to move away from an emotional understanding of stuff to this more precise measurement that science entails? Again, any thoughts you have about that?
Well, I'm glad you brought that up, because what's really interesting from my perspective as a mathematician is that at the core, what sets mathematics apart from every other discipline is that in mathematics, you can uncover and unearth absolute truths. And if you think about it, you really can't do this in every other discipline. I'll give you a great example. The Pythagorean Theorem, right? The statement that in a right triangle in the plane, the square of the hypotenuse equals the sum of the squares of the other two sides of the triangles, their lengths. What I mean by absolute truth is that this is a theorem, and there's all sorts of very neat ways to prove it. And because it's a theorem in mathematics, it's something that was true when Pythagoras proved it thousands of years ago. It's something that's as true as it was then now, and it will be true forever. So unlike a physical science where you have a scientific method, for example, and an experiment, 100 years from now might replace Einstein's theory of gravity with something else, or some of the best theories we have for everything from fields of psychology to economics, mathematics really is about discovering the absolute truth. And I think that sets it apart. So you're totally right. When we're reading some of these research papers, really, as a researcher and as somebody who's an academic, somebody who's thinking about using this information for something else, one of the central questions is what is the absolute truth of what I'm reading? How can I completely be sure that there's a pattern here, that there's a causality? And I think that's really, again, where mathematics really stands apart from the other disciplines.
And I'm glad you brought up this issue of absolute truth, because my experience of mathematicians, and I'm going to say something provocative and challenging now, is they have a certain despair or disdain for non-mathematical subjects, precisely because what drives mathematicians is that fascination with absolute truth.
Right.
And they don't like anything that isn't absolute truth. So that's why they, in a way, I think they don't understand why anyone's doing anything other than maths. What's your reaction to that point?
Well, it's funny because my background is actually that of an applied mathematician. So I kind of like to think of myself as occupying the gray area between a pure mathematician, so to speak, whose, absolute truth is near and dear to that person's heart, and a scientist, somebody who works on intuition, perhaps from the real world, notices a few patterns, but maybe two or three, too small a sample size to make any, deductions. But, kind of like Newton maybe sees a falling apple or something and wonders, how general is this phenomenon? And that's sort of a very scientific approach to mathematics. But again, once you go down that road and you start asking what are the real truths that are, that we're studying here, at that point you're thinking a bit more like a mathematician would, even though, in my examples and in my background, certainly I'm motivated a lot by physics is my research background.
And that's another really interesting point that goes to the heart of psychiatry and psychology. People come as patients to doctors and they're clinically depressed, their boyfriend or girlfriend's left them, and they're a little bit caught up with the notion that they're dealing with a problem that no one's ever dealt with before. And that's one of the key issues. They're not thinking about how universal is this problem. The power of what happened when that apple fell supposedly on Newton's head, though it's arguable whether it really happened or not, was not that he discovered gravity, but he suddenly realized something, which was the force that drew the apple to the center of the earth was the same force that was holding the moon around the planet Earth. And it was that leap about the idea that this force then explained, how galaxies stayed together. It's the universality of the force, is the power of the idea. So maths and science is about moving from the particular to the general. Again, any thoughts about that?
Right, that's exactly right. I would add that Newton's law of gravity is often called Newton's universal law of gravitation, and as an illustration of this small but important distinction, Newton's law of gravity is still fairly accurate, and we use it, we teach it in physics textbooks and at college level curricula. At the same time, fast forward 300 years, and Einstein came around and said, well, there are some certain experiments with a few planets in the solar system where this law of gravity doesn't quite yield the right results. And he came up with something completely different, which, revolutionized what, our understanding of the universe. So again, in much the same way, the scientists are trying to find these absolute truths, but the real world is much messier than mathematics, which is much nicer.
Okay, so let's go to the beginning of the book. And the first few chapters are about food, calories, dieting, and weight loss. Now, this is very interesting because everyone's worried about their weight, and they're trying to lose weight, and they're often failing miserably. And that, of course, is why there's a billion-dollar diet industry out there coming up with the very latest diet. So the view within psychology and psychiatry, the real problem here is motivation. People are not motivated enough. They don't really understand the sacrifice they need to make in order to lose weight, and that drives them to seek a quick fix. And they're never going to make it that way. But I thought what was really interesting here is you have a different analysis, which is the reason why people are not losing weight is they don't understand the maths. And if they understood the maths, then actually they have a much better chance of succeeding in this very important and frustrating part of our lives. So before we get into the detail, again, what's your response to that idea?
Yeah, I couldn't agree more. One of the really interesting parts of writing this book was I tried very hard to come up with spheres of life that would help the reader see mathematics as something that was truly empowering and useful. And I couldn't think of anything more, every day than health, wealth, and love. And I started with health because that's almost, on a day-to-day basis, it's one of the things that we really do not think of math as useful for that. We think of a doctor, we think of all sorts of gadgets, if you will, or a Fitbit, so mathematics is to me the most decoupled from the three. Arguably love also, but I wanted to think a little bit about how I could start the book with a very simple explanation. And, I'm sure we'll get into it, but things like 4 calories per gram of carbohydrates, things like that, simple numbers, and what turn out to be effectively linear functions to exactly do that, to help the reader understand that if you start from zero, there's actually mathematics that will help you understand all of the numbers in these nutrition facts and all of the foods that we eat.
And the other thing that your book does is say that the maths will unpack the mystery of why you're not losing weight, which is there's no mystery. If you understand the maths, it explains it. And therefore, the maths helps you understand what you have to adjust and where you have to adjust. So let's start with one key concept, which is resting metabolic rate. So this partly explains why it seems I hardly eat anything, but I'm fat. And my neighbor, who seems to gorge, doesn't seem to get fat. I mean, there's more complicated things than that. Tell us a little bit about resting metabolic rate and why that's so important.
Sure. So, this is a rough definition, but this is the amount of energy. Typically, it's measured in a 24-hour period. The amount of energy that your body would burn if you were awake, but otherwise at rest. So imagine, you're a couch potato for 24 hours and you're awake and you're just, binge watching every single show that you could stream on your computer. But you were not, walking around or on a treadmill. So if you try to figure out how many calories that would be, that's what the resting metabolic rate is. And there are different ways to estimate this. The most accurate formulas that we know of at the moment were published in 1990, the Mifflin-St. Jeor equations. And they use your weight, your height, your age, and then whether you're male or female to estimate your RMR. And what's really interesting about these equations, I write about them in the book, is that they're basically the same equation, except the resting metabolic rate for men is 166 calories greater than the resting metabolic for women if you are the same weight, height, and age. So in other words, men's metabolism, if you will, is 166 calories burning faster than a woman of the same height, weight, and age. And there's pretty simple reasons for that. We can get into that, but that's sort of in a nutshell what the concepts are.
Okay, what about this total daily energy expenditure? Tell me a bit about that.
Sure. So your resting metabolic rate, because it's based off of just being a couch potato for 24 hours, it's not a very realistic estimate of how many calories you do burn in a day. So most of us, clearly we walk around, we go to work, we eat. So there's a notion of how many more calories does your body need to do everything else other than just keep your organs going. What about walking? How many calories does that burn? How about digesting your food? So when you start adding all of these additional sources of caloric burn to the RMR, that's when you get to what's called the total daily energy expenditure. And there are different ways to estimate that also that we can get into, but that's how you get to that number from the RMR.
Okay, so you really got to get a handle on some of these mathematical concepts you're saying in order to figure out what's going wrong if you're not as fit as you'd like to be. So let's cut through some of the other stuff, which is still fascinating and interesting and easy to read, but get to some of the take-home messages. And one interesting take-home message that I was certainly less aware of than maybe I should have been, given I'm a doctor, is the benefits of eating more protein and less carbohydrates. Could you say something about that?
Sure. And let me just mention that my brother is actually a personal trainer, so I know a lot more about this than I probably should, just being a mathematician. But one of the really interesting things about protein is that one of these components that gets you from the RMR number to the total daily energy expenditure is called diet-induced thermogenesis. And basically that means that when we eat food, that food gets digested, and that process takes energy. So your body has to expend calories to digest some of the calories you just ate. And not all of the macronutrients that you eat take the same amount of energy expenditure to digest. So protein turns out to take the most amount of energy to digest and break down. Part of that is biochemical, but in a nutshell, if you think about eating 100 calories of protein, then about 20 so calories of that are going to be wasted with your body trying to just unpack the proteins and digest them. This is in contrast to carbohydrates and fats, which if you eat 100 calories of those might take about 5 or 10 calories of that 100. So what's really interesting basically is that the more protein you eat, the fewer net calories you're getting compared to carbohydrate or fat. So there's all sorts of studies on this, and I mentioned some of these in the book, that diets that are higher in protein relative to other diets actually help you lose weight faster and keep it off longer. Because there's also a research showing that eating more protein helps you feel fuller for longer. So protein is this sort of miracle macronutrient that helps you feel fuller for longer. It takes your body a lot of energy to digest, and in that way, the net calories that you've eaten are lower. And certainly for recuperation, if you go to the gym or if you work out, protein is one of the main sources of refuel and rebuilding for muscle fiber tissues. So it's got all these benefits, but it's really hard to wrap your mind around unless you think a little bit about the very basic thermic effect of it.
And what about the benefits of fiber? Because that was another interesting key take-home message.
Yeah, so fiber is also another one that has been really, really interesting because fiber is, especially soluble fiber, has been shown to have this amazing benefit to be able to lower your LDL cholesterol. And that's usually referred to as the bad cholesterol, although, our understanding of cholesterol is continuing to evolve. But long story short, soluble fiber in particular forms kind of a gel when it's eventually digested that kind of circulates the LDL and helps you get rid of it. So eating more fiber, specifically soluble fiber, oatmeal, for example, is a great source of this. So are, to some extent, beans and perhaps apples and garlic. These types of foods have many benefits. First, from the soluble fiber viewpoint, they improve your lipid profile. But also fiber is one of those nutrients that your body can't digest that well. Actually, there's a little bit of a myth here that you might see in some of your food packaging, the net carb myth. Let's say your food contains 10 grams of carbohydrates and it's got 5 grams of fiber. Then you subtract the two. The idea being that your body cannot digest fiber. But that's not totally true when you look into the research, right? It really depends on the type of fiber. And the sort of consensus that I was able to find from the United Nations food scientists are that actually instead of 4 calories per gram of carbohydrate, in terms of energy yielded by digesting that, fiber yields about 2 grams per 2 calories per gram of fiber ingested. So it's not zero. But it's certainly less than if you ate, a croissant or something. But that's another reason that fiber is so useful, because you're eating food, so you're feeling full. But again, your body is not getting as much energy as it would get if you ate some piece of white bread, for example.
So one of the theses then is that if people understood the maths a bit better, they would stand a better chance of actually being more effective in this very frustrating area of people's lives.
Right. And, at the end of the first chapter, I have this, equation, which I put in quotes because it's not really an equation, but I say math plus discipline-specific research-based knowledge equals empowerment. So I'm really saying that, there's a combination here, especially in 2019, where we have the internet at our fingertips. We have lots of open source journals like PLOS ONE and Scientific Reports and others. It's really easy for any one of us to log on and download actual research studies. And there's an accumulation of a body of knowledge and best practices and all sorts of, results. And if we can learn to apply even mathematical principles, not necessarily math itself, in the way that I'm articulating it in the book, then we can see that marriage is a really happy one to empower us to lead better lives.
Okay, so there are lots of other really fascinating chapters about how to budget, how to invest, but I want to go to the chapters towards the end of the book about using maths to solve the mystery of love. And the first bit is, and this is a very common problem today, how to find, and I like the fact you use a mathematical principle here, how to find the one, how to find Mr. or Mrs. Right. And you start in a fascinating place, which is a famous equation called the Drake equation. And this is about the search for extraterrestrial life. So what's the link between the mathematics of the search for extraterrestrial life and the mathematics of finding Mr. or Mrs. Right?
Yeah, that's a great example. And, again, it's a really nice illustration of this mindset, this mathematical mindset that the book tries to illustrate. When most of us go about trying to find a date or trying to find, the one, as I mentioned, we might go through a certain search process. We might, ask a friend or ask family members, for questions about, do they know anyone who might like, for example, the same things I like, or do they know anyone who they think might be a good match for me? But in a sort of mathematical mindset, you might think of the question a little differently. You might say, okay, I'm trying to make a match. And if I'm trying to match two objects, how do I match them in a way that I know, again, going back to this absolute truth, in a way that I know is gonna result in a strong match? Then you might say, okay, well, there are certain factors that I want these two objects to have, so that's going to be a strong match. And that's where you start thinking about what are these factors? So it becomes a personal question of what am I really looking for? Am I looking for someone who enjoys long walks on the beach like I am? Am I looking for someone within a certain age range, within a certain geographic location? And that sort of thinking is very similar to what Frank Drake did, an astronomer, in 1960 when he started thinking about how to estimate the number of intelligent civilizations in the universe. Very similar idea. So he thought, I want to find out what this estimate is. What are the things that I would need to know? And he started thinking, well, if it's an intelligent civilization, it would need to live within a certain distance from a star that perhaps might, be able to support life. So, what's the percentage of, solar systems or systems that might support such a configuration? And as he added requirements, he started to think about how this might come together. And he thought, well, I'm going to multiply the percentage of that represents the first requirement times the percentage that represents a second requirement, and so forth. And that gave him his estimate. So in the book, I write about a very similar approach to finding a number of potential partners, I say. So I say, for example, take the population of the area you're looking for love in, and then multiply that by the fraction of the population matching your desired sex, male, female, for example, and then multiply that by the fraction that lies in your desired age range. And then you can keep multiplying by these numbers to try to get a sense of your particular requirements, if you will. And this is sort of a Drake equation-like approach. So it's very interesting that it mirrors the search for extraterrestrial life when in this case you're looking for, a soulmate, effectively.
But you also say something about you can't start the search without having some sense that what you're looking for exists, which I thought was a very interesting idea,
right.
Which is at the fundamental. Whenever you construct an equation, it helps you think about what are your assumptions. And I wonder if you could say something about that kind of having a sense of, before you can start searching for it, know that it exists.
That's right. So, there has to be some reason for you to believe that this person out there that you're looking for exists. If you start off and you convince yourself that that person doesn't, then it's almost like there's nothing left to do. How do you search for something you believe does not exist? And really, to take that to the next level, this is actually a very core issue in mathematics as a whole. There are many, many theorems, for example, that have the form existence, uniqueness theorems. So we mathematicians care a lot about making sure things exist before we go off and finding them. And then if they exist, we'd like them to be unique, meaning there's only one. So you can take the same approach, and that's sort of where I was heading with this. Although, it is still kind of fun to crunch the numbers. But I will say, as I write in the book, the numbers might be depressing. You might find that of 5 million people in London or something, there might only be 2 or 3 that match all of your criteria. But at least, they might exist.
Okay, so then the next bit is the next bit of the chapter is why hiring a secretary is like dating. Can you explain that?
Yeah, so this goes back to what was called the secretary problem, which I think dates back to around 1950 or so. And the idea was if you're an employer and you want to hire a secretary, let's say, and you have 100 applicants, um, all of these people might be also applying to other positions elsewhere. So you think to yourself, if I have to interview all 100 applicants and then make a decision, actually the person I would return to hire might have already accepted a job offer somewhere else. So again, thinking differently in this mathematical mindset, you might ask yourself, how many people should I interview and then stop and then hire from the best that I have seen so far? So, if you have 100 applicants, should you stop at 10? Should you stop at 30 or 95? And this becomes a mathematical problem. And there's a lot of uncertainty associated with this, right? So there's so many variables to think about. So it becomes a probabilistic mathematical problem. And what I show in the book is that actually there's something called an X strategy. And the idea being that if the number of applicants is large enough, even when there is as few as 20 or so, what ends up being optimal is for you to interview 37% of them to get a sense of who the best applicant in the pool has been, but reject all 37% of those. And then from the 37% up that remains, select the best candidates, the one that was better than the first 37% that you interviewed. So it's a kind of a strange strategy, but it turns out if you do this, you are guaranteed by mathematics to have selected the best candidate in the entire pool at least 37% of the time. So this is, called the 37% rule. And it came up in this secretary problem, but actually it's used in all sorts of other places. And it's a general mathematical result, not only confined to hiring.
But there's some really interesting mathematical proofs of a kind of thing that we know intuitively, which is it's very unlikely if you settle on the very first person you've ever dated that you probably got that one right. In other words, you need to go around sampling a little bit before settling on your decision. And we see that over and over again. Certainly when you do marital therapy, your heart sinks when people say, well, this was the very first real relationship I had. So does mathematics back up that intuition then?
Yes. And what's actually interesting is that I don't think I put this in the book, but it turns out you can morph. This is another great thing about mathematics. You can connect seemingly disconnected things together with mathematics. It turns out that, as I've described this strategy, you have 100 applicants for a job or to be your soulmates, whatever the, criteria are. And you're trying to choose the best one from the 100. It turns out that you can morph the problem, if you think about dating and marriage, for example, to the following. You can say, I have 30 years left that I am willing to get married somewhere in that time period. How much time should I spend looking for my marriage partner before I do something else? And you can morph the problem of hiring a secretary to that problem. And it turns out that 37% is effectively the same answer. So if you take however long of a period you want to look for love in marriage, and you take 37% of that, if you were to reject, marriage to the first 37% of years of people you meet, and then start onward from that, looking for the person who was at least as good or better than everyone else you rejected, then with probability at least 37%, you will have chosen the best person. So, these are semi-complicated concepts, but one thing I just want to point out is how incredibly powerful they are. Even in the secretary problem, even in the marriage problem, there are so many variables. There's so many variables about matching to people, about matching an employer with an employee, and yet we can make these, again, absolute truth statements with mathematics about how often you will have selected the best candidates, right? So every time I think about this, it's very, very neat.
So if I was 27 years old and I thought I want to settle down by the age of 34, then the 37%, I'm going to call that roughly a third rule, says that after I've spent a third of that time dating, I should have got a sense of the quality of the candidates out there, and I should go for the next best candidate in terms of the time frame. And also, if I'm thinking there's 100 possible people to date, I should date roughly a third of them and then pick the next best person that comes along.
Exactly. And I like to think of this, as you're doing your, let's say with 100, as you're interviewing or dating the first 37, then I like to think of this as the leading contender, which is, again, a tie-in to what many of us do anyway. So as you're interviewing 37 people, who stands out in your mind as the best of the 37? And then this rule basically says when you get to 38, start looking for someone who was better than your leading contender. And that's the person you would hire or date, or marry.
Okay, so now we get to kind of like a speed dating situation, if I've got that right, or a dating situation in terms of like going to a dating club or a dating evening where you meet lots of different people, and you get to a mathematical solution to that called the Gale-Shapley algorithm. Tell us a bit about that.
Yeah, so this is fascinating. Again, what differentiates this tidbit from what we were just talking about is that, in the secretary problem, you know very little about the people you're interviewing or the candidates for love. In this, what's called the stable matching problem, the assumption is that you know everything. So, the best way to think about this is a millionaire matchmaker or somebody who has very detailed information on every single person that is in the matchmaking pool. And the way I set it up in the book is that there's, picture a large room and there's a rope down the middle. And you have all the men on one side, you have all the women on the other side. And, later on in the book, I talk about the heteronormativity assumption of this. But, picture you have all the men on one side, all the women on the other side. And both groups know everything about each other. So the matchmaker has given everybody detailed files with videos and bios and all sorts of information. What the Gale-Shapley algorithm does is that it creates a stable matching. What that means is that at the end, it matches every man to every woman in pairs. So you have to have, as many men as women to begin with. It matches them in pairs such that mathematically there is a guarantee that no one will ever cheat, which I think is just a crazy, result given the real world. And I run through how it does this in the book, but long story short, the algorithm has the men choose first their top choice. And then the women have a chance to, rebut that, if you will, and choose back their top choice. And it goes back and forth in a sort of ping pong, if you will, until the matchings that are produced can be shown to be stable, again, by a mathematical proof.
Okay, so we're going to move on now to you've met someone and you're thinking about, are they Mr. or Mrs. Right? We're going to talk about research, very interesting research about couples done by the Gottman team, and the notion of the mathematics notion of a dynamic system, which I thought was fascinating. But one thing that you didn't mention in the book, and I just wanted to get your opinion on it, because I think it's also relevant and it is about maths to some extent, is network theory. And network theory says that we tend to think about ending up with someone who's a friend of a friend, because we meet people that are friends of our friends. But what network theory says, and I'm interested in your opinion, is actually, because you know your friends very well, and therefore you know their friends very well, if you keep camping out in that territory, you're just going to meet the same people again and again. And what you should actually do is exploit the people you know really much less well, because their friends are much less likely to be people you already know. So I think the mathematics of network theory proposes a very interesting dating solution, that you're wasting your time hanging out with your best friends. If you want to meet someone, spend more time with people you hardly know, because that's the better way of expanding your network into being more likely to meet someone you haven't already met as a dating prospect. I don't know what your thoughts are about that.
Yeah, I think that's a very interesting approach. And, I'm familiar with a little bit of that research. For example, there's research showing that if you are surrounded by smokers, you are more likely to become a smoker. And you can, replace some of these traits or behaviors or activities with many other things, such that the network that you surround yourself with certainly have a larger influence on your behavior than the people you're not surrounded with. So I like that approach. I would also say it's also compatible with what we were saying earlier in the beginning of this chapter in the book, that you want to think outside the box, if you will, but you want to think different about how to approach real life problems that you're trying to solve. And certainly, going to your friend and asking him or her for, some advice about someone else they might know who might be compatible with you is a reasonable thing to do. But if you think a little different, think a little mathematical, network theory, or even some of these other concepts, again, you might have some interesting conversations at the least.
Okay, so the notion now of couples and a dynamic system that you go negative, your partner then goes negative, you go even more negative, etc., etc. The fact that people react and there's a dynamic system is, I think, mathematically a very interesting way of thinking about couple behavior. Now, this research you quoted from Gottman refers to the fact that they could predict which couples are going to eventually get divorced several years into the future with 94% accuracy. And what they said was couples with low negativity thresholds, where spouses are noticing and responding to negative behavior when it is less escalated, had the highest chances of having a happy, healthy marriage. So what that seems to mean, and I'm interested in your reaction to this in plain terminology, is if you can spot when your partner's not that happy, but spot it early, or let's say is a bit annoyed with you, but spot it early. In other words, before the other person has to escalate or escalates their negative mood, so it becomes barn door obvious, let's say, then you've got a better chance of surviving, because it means you're sensitive to small dips in mood and you do something to repair it. Again, what are your thoughts about that?
Yeah, I totally agree. And in that research, the negativity threshold was defined as the point at which negativity has an impact on the partner's immediately following behavior. So really what the Gottman team, did, and they did this by just hooking putting couples in a room and giving them very controversial topics. You can think, for example, of abortion, things like this, and measuring everything they possibly could about how the couples communicated with each other. And then they went back and they applied mathematics and statistical analyses to try to tease out what were some of the driving factors that could explain the differences in outcomes later on in terms of divorce or in terms of breakups or happiness. And that's how they got to all of this research. And the negativity threshold was one thing that they pointed to as really the central core idea. This notion that if you and I are having a conversation about some, controversial topic, and I'm starting to get, for example, very angry, or you're starting to get very frustrated, if we are able to sense that and de-escalate fairly quickly, then that sort of interaction, the Gottman team showed, predicts very stable and happy interactions going forward. And I think, again, that says a lot about being present. It says a lot about being in tune with your partner, about having open communication. So, it's very much about, it very much goes in line with what we know intuitively, if you will. But really, this 94% accuracy number was one of the very shocking results that came out of the research.
And the other really interesting concept you refer to in the book is this Goldilocks zone, which in a way goes back a little bit to the Drake equation. The Goldilocks zone being the perfect place for a planet to be in terms of the distance from the sun to allow water to exist and therefore maybe life to exist and other key features. But there's a Goldilocks zone in relationships, you say. The researchers found the Goldilocks zone, too quick or too delayed a response, could eventually destabilize the relationship. Put this together with the negativity threshold found by Gottman's team, and we arrive at an intriguing possibility. Perhaps relationships are made stronger by each person having a low tolerance for negative behavior and each letting the other know fairly quickly when such behavior arises.
Exactly.
So have you noticed this a bit more, having now written about it, in relationships in general? Because as a couple therapist, I do a lot of couple therapy, I think it's a really big issue. And a lot of women in particular, I'm going to say something slightly politically incorrect, come to me and they complain about a new boyfriend that he doesn't notice when they're upset, and they have to get barn door angry before they react. And you know that's a danger sign as a couple therapist, that really they probably ought to leave. But what happens is the woman stays and just keeps escalating negativity in order to get noticed, and doesn't realize the very fact you're having to escalate the negativity to get noticed is a very dangerous sign indeed.
Yeah, and it's very interesting because so I have a 3-year-old and an almost 6-year-old. And I've come to reevaluate and revisit some of the concepts, particularly this one in the book, throughout the time that I've been thinking about different parenting philosophies. And I see this play out in my children all the time. So, if my 6-year-old, does something and there's no communication and it sort of simmers in her mind and I see her get more agitated as time goes on, there's again that question of at what point do you intervene as a parent? Do you immediately solve your child's problems, or do you, let them and encourage them try to figure it out for themselves? But then if you're completely hands off, that's probably not a great way to do it either. So similar intuition, there seems to be a Goldilocks zone for helping people just resolve and think through the issues that they're facing, either themselves or with other people. And what's really fascinating that I found in writing the book is that, again, much of this intuition, when you dig deep, really is supported by the research. And when you think about it mathematically, is also supported by this edifice, if you will, that leans towards some of this absolute truth that we were talking about at the start of the conversation.
Okay, so we're running out of time a little bit. The book, again, just to remind listeners, is called The Calculus of Happiness, How a Mathematical Approach to Life Adds Up to Health, Wealth, and Love. But I want to conclude by asking you a question that may lead you to run screaming from the room, which is that you're a professional mathematician. You're clearly passionate about maths and an enthusiast. And one of the things that I think is a subtext about the book, which is you're lamenting the fact that more people aren't turned on by maths. And obviously, there's a genetic theory that maths, people, an attachment or fascination with maths or a facility with it has a slight genetic basis. And there is a little bit of evidence for that. But I put it to you as an educator that something's going wrong with the way maths is taught, which explains to some extent why so many people are just turned off by maths and leave the education system, not embracing the subject. I mean, what are your thoughts about that? What's going wrong with the way maths is taught at school, or how people are introduced to maths? Or am I blaming the wrong place?
No, I think, I do consider myself first and foremost an educator and second a mathematician, which might be a little bit surprising to some. But the reason is that my core driving goal is to get people excited about math, to make mathematics accessible, concrete, applicable, empowering. And really all of that goes to how do you convince people who might not think of themselves as, quote, math people, that in fact they can have meaningful experiences with mathematics, that they can be empowered by the subject. So honestly, I think there's a lot of psychology. So as an educator, much of what I do is to try to break down these misconceptions. So I teach at Wellesley College, for example, which is a women's college. And there's a lot of research that has come out over the past few decades comparing math anxiety in women to comparing math anxiety in men. And it turns out that one of the things that you can do for men and women, but specifically for women, is to foster what's called a growth mindset. So the idea that, if you do a math problem, for example, and you get it wrong, women are more likely to internalize that as saying, I'm just not good at math, compared to men. So if you as an educator are aware of this research and you're aware of some of the interventions you can take, you can jump in and say, well, that's okay. This is not something that you get at the moment. You don't get it yet. But let's try to figure out, where you went wrong, or let's try to figure out how we can build on the solution you do have. So even that simple tweak, right, this adopting a growth mindset, if you will, again, the research shows leads generally to success much beyond just saying, okay, I guess you're not good at math, go be an English major or something. So I think as an educator, we do have a responsibility to think a little bit more deeply and substantively about how we can make mathematics more accessible. And again, there's decades of research literature on interventions and high impact and best practices. So I'd love to talk more about that.
Okay, so Oscar Fernandez, Associate Professor of Maths at Wellesley College and the author of this fascinating book, The Calculus of Happiness, How a Mathematical Approach to Life Adds Up to Health, Wealth, and Love, published by Princeton University Press. Oscar, thank you very much indeed.
Thank you, Raj.